Good morning to all. Today we are going to see about unit 3, that is input output interfacing. So basically interfacing is nothing but you are going to communicate with outside world with the help of some other devices. The devices may be either a keyboard display or LED display or any other parallel communicating devices, or either if you are going to control some of the traffic light signals, means you are going to use some interfacing devices. The interfacing is mainly deals with two types. So one is your memory interfacing, second one is your IO interfacing. So memory interfacing in the sense the data can be read or write into the memory or from the memory with the help of some interfacing devices. Input output interfacing is nothing but you are using some keyboards and displays as interfacing devices in order to communicate with the outside devices world. So these are some examples of peripheral devices which are to be developed by the developed in order to communicate with your processor. So first one is your 8255, which is nothing but a parallel communication interface. 8251 is meant for serial communication interface. Similarly, 8254 for programmable timer, 8279 for keyboard and display, 8257 is for DMA controller, 8259 is for programmable interrupt controller. Today we are going to see about a parallel communication interface, that is 8255. First of all, what is the difference between serial communication and parallel communication? In the sense, in serial communications there is some conditions or restriction whether the whole 8-bit data is transferred to external devices or not. So that is a major question in serial communication. In serial communication, only one bit can be transferred at a time to the outside receiving end. But with the help of some parallel communication interface, a bunch of data is nothing but 8-bit data. If you are in need to transmit a 8-bit data, means that 8-bit can be transferred from receiver sending end to receiving end without any errors. So that's why parallel communication is preferred over serial communication. So first, the serial communication will have a different types of modes. We are already aware of these communication modes. That is a transmission modes. First one is your simplex. In simplex mode, only one end, that is either transmitter end or receiver end, can communicate at a time. Both from communication from both ends is not possible. For example, you are going to transmit a particular text from a computer to the printer will print that is. The printer cannot send back its data to its computer. So that is not possible. So it comes under simplex mode. Next one is your half duplex mode. So half duplex mode, the data can be transmitted in both the directions, but not simultaneously. Not simultaneously in the sense, the sender also send, but receiver also send, but at a time they can't send the information. That is a walkie-talkie. So you might have seen in day-to-day life, walkie-talkie is used to communicate both ends, but not simultaneously. Next one is your full duplex. Full duplex is nothing but the mobile phones we are using in our daily life. That is both the sender can talk and receiver can send the data. These are the various modes of transmission in serial communication. So we have omitted a serial communication because of its drawback, and the major topics in second unit is a parallel communication interface, which is nothing but 8255 IC. It is also called as programmable peripheral interface. It has three bidirectional state buffers, 8-bit buffers. It consists of 24 programmable pins, and it consists of three ports, namely port A, port B, and port C. The port C is further divided into port C upper and port C lower. So these are the various modes of operation. That is, the 8255 can be operated in two modes. First one is your bit set reset mode. Second one is your IO mode. Further, this IO mode is classified into three modes: simple IO mode, strobed IO mode, bidirectional data transfer mode. So this is the pin diagram of 8255. It consists of 40 pin packages. These 40 pins is meant for three ports, I said earlier. No, so three pins. So port A will hold the data of 8-bit, port B will hold the data of 8-bit, and port C will hold a data of 8 bit. Together, for all the ports for addressing lines alone, it occupies nearly 24 pins for this process. So remaining pins are allocated for data lines. So D0 to D7. This is your 8 pin. So 24 plus 8, 32. So remaining 8 pins won't be allocated for supply and ground and reset option and mode selection. For this operation, they have allocated remaining 8 pins. So 30 to 40 minus 32, it comes 8 pins. Okay. So as I said, no. So this is a read bar. This is a chip select. This is a ground pin. So this one is your address line. So next one is your, this is write pin. This is a reset pin. This is a supply pin. So remaining these 8 pins. So 5, here it is 3 pins. The leftover pins are allocated for mode selection and ground and supply and reset option. So it consists of mainly 4 sections. First one is your data bus buffer, read write control logic, group A control, group B control. So first one is your read write control logic. With the help of these read write control logic only, whether the transmitted data can be read into the processor or write into the processor, and depends upon these A0 and A1 A0 signals, the operation, the memory operation or input output operation, the mode of operation can be selected with these status signals. So that's why it is called as a control logic. So next, the read data or write data, the data can be transferred to your data bus buffer. From the data bus buffer, it is transferred to your internal bus. The internal bus, through the internal bus only, the data can be transmitted from a sending end to receiving end. And the internal bus will transfer the control to a port A, B, or C. So generally it consists of two control blocks. One is your group A control, another one is your group B control. So group A control will hold a value of this port A and port C upper. So port C upper in the sense P4 to P7. So only these 12 pins will be presented in present in group A control. In group B control, again 12 pins. So totally 24 pins for this communication process. So once if you are in need to control a group A and you are in need to use port A and port C upper means, the group A control will send a transfer to its internal bus, and from the internal bus, these ports will access the data and transfer to your IO devices. Either it may be some other display devices or DMA devices, whatever it may be, it will access with the help of those devices. So individually block wise, we can see this one is your data buffer. So the data buffer will be used to declare the whether the data will be taken as a input or output. Next one is the read write control logic. As I said earlier, the which port is to be selected depends upon the these control signals A0, A1, and chip select. Okay. So next one is your here is a 8-bit port. So this is a status bit. So this command word indicates which mode of operation is done. So from this we will clearly understand right. This is the control word format for 8255. So frequently they will ask some few questions in competitive exams like NPTEL courses and all. So here it is depends upon this D7th pin. Either it may be take 1 or 0. Each pin will hold a value of 1 or 0. Depends upon input. For example, if D7 is 1 means the 8255 will operate in input output mode, and D4 is 1 means port A will be chosen and the port A will be operated in input mode. So that is the control word format. So are you all clear with this control word format? If group B is under operation means the D0, D1, D2 pin will be selected. So depends upon these input, the processor will start to do its operation. So in IO mode, the further it is classified as basic IO mode. So basic IO mode will have hold all the ports, port A, port B, port C. And mode 1 is called as a strobed input output mode. Here it is used for handshaking. It is also called as handshaking mode. Some of the handshaking signals will be used here. And mode 2 is called as a bidirectional data transfer mode. Here only group A and group port C, that is a port A and port C, will be used for handshaking purpose. So these are the signals which is present in the group A controller in order to transfer the data from processor to its your external device.